for coming, and you will present Java to Python. So thank you very much.
So, that okay? Okay, so. Hi, so yeah, this talk from Java to Python. My name is here. I work at this company. We are recruiting, but we are in New York and London, so if it's relevant to you, let me know. And I put some kind of code. I just did it today on GitHub for the things that we're going to go for. So you can later look at it. I just did it today, so I need to maybe polish it a little bit. And there's some stuff I was working there when I learned Python, so don't look at that. Just look at this one. So this talk is basically my own experience. I used to work in a company, like a startup company, and we kind of worked in Java. A little bit after we started working in Java, I kind of started, getting the hang out of Java. We were purchased, and then my new company was doing Python. So basically, I started learning Python. And what happened was that I started writing Python. We have this kind of process whereby when you submit code, people are reviewing it, like a code review. And many times I was doing things, and the code reviews I was getting was like, Python is not Java. You don't do it like this. Python is not Java. You don't do it like that. And I was like, all right, I got it. But what do I do? Because you know a few things usually when you kind of program in one language. The question is, can you transfer them? Can you try and use them in the new language? So how many here have done Java or are doing Java? Okay, all right. So I hope that this will be kind of useful for you, especially if you started with Python, because this is not like very kind of sophisticated stuff going on. But I hope that even if you haven't done Java and you kind of think about design patterns and stuff, you'll be able to get something out of this talk. So let's say what we are going to cover here. So I'm going to have some explicit Python code over here, where we basically kind of go through some code samples. There are going to be some good code samples and some bad code samples. I try to kind of decorate it or put it like an X on the one that I think are not good, the anti-patterns, and V on those that I think that are good. As I said, I don't think it's, I'll try to convince you that the patterns are good, and I'll try to kind of showcase why they're good, but I guess, you can still argue, and the questions you can still ask, maybe why certain things were chosen the way they are. Things that are not covered is that I didn't even write Java in here to make it kind of shorter, and because everyone knows that Java is much more verbose, but also because I kind of assume that it doesn't really matter. It's how you want to do it now in Python. And I'm not making exhaustive list of differences. I wish I could be in the previous talk, because I just don't speak Italian, but I wanted to see kind of what was the comparison over there. So I'm not going to make an exhaustive list of differences, although I'm going to give at the end URL for where you can do it. And I'm not going to do a low-level comparison of saying, here you have a class, here you have a module, because I guess, once you start with Python, this is something you pick up really quickly. I'll try to talk about the higher constructs. And I'm not going to say which one is better as well. I mean, I guess if you're here, you think Python is better, and that's I don't argue with that. So far, so good. So the concepts that we're going to go for, I'm going to go through some data classes. I'm going to talk to how you protect your instance fields, if you'd like to do it in Python. I'm going to talk about some factory methods. And I'm going to talk eventually about decorators and adapters, which might be like the heaviest in terms of stuff, in terms of like the complexity. But really, I think once you get the hang of it, and I think that's the thing that kind of took me most time to get the hang of, it's not that hard, I think, and very, very useful. All right, so let's start. So data classes are usually like the containers. In Java, they kind of containers to just like bundle up some stuff together. Again, in Java, we have classes for everything. So you have a class, you just like put a few things over there. And in Python, you can also define classes. And let's say that we want to kind of represent a point. So this is actually how I started, you know, like I have a point and I'm having an x and y. So I'm having the init, which is like the initializer, like the constructor. And then I'm defining my getX and setX. Obviously, it didn't pass. It didn't pass, and good didn't pass. And I think this is a bad example of writing Python. So I think in Java it kind of makes sense because you have private instances. You want to encapsulate stuff, and then you have getters and setters. In Python, it doesn't really make sense to have it on your attributes because the getters and setters here want to say, you know, if you want x, you call getX. If you want x, you call setX. Nobody is looking for these things in Python. Nobody's actually looking for your getters and setters because they're just going to look for your class point x, point y. The reason is, I guess, is because you have access to them, so why hide this access behind getters and setters? Again, in Java, it kind of when you have a private thing, it doesn't really exist. So you kind of do that, and you have loads of tooling around you to kind of help you, and you know your IDE, you can create these getters and setters. But in Python, it doesn't make sense because everyone can access x and y, so you're trying to protect them maybe by putting them here, but there's a huge gate over there, open, everyone can just access your x and y. So don't do it. So how can you do it? I think this is a great solution for that. Just use a tuple. Because in Java you don't have containers by default, then you need to kind of define a class for everything. In here you don't. You have like a data structure in the language for these things, for x and y. And then you kind of decide my point 0 is like, you know, 0, 0, and that's fine. I think this is fairly good solution, but it depends kind of how far kind of your class circulates. My kind of thing with tuples, they're really great if they're like used internally and they're used really quickly between things. But sometimes you kind of want to maybe pass them around to many more classes or many more people going to touch that code. It's not just like, you know, something internal. And then it's kind of starting to get a bit harder to kind of track or a bit messy because at this point, you know, usually you say x and y and the order is kind of simple. But sometimes you want to say, I don't know, you want to store 5 different telephone numbers. And then it's not really clear whether the first one is the home or the office or whatever. And the tuple doesn't really provide it for you. You just remember the indexes, the indices. So you can use a name tuple, I agree. But I think name tuple have their own problems of like equality. When you want to compare like name tuples, it actually just compare them by the indices and not by the name of the class itself. So a fairly good solution in Python is just to say, you know what, just forget about the getter and setter and use that. This is a fairly good solution for that. And if you want to add some behavior to this class, there are 2 ways you can do it. You can do it yourself by, you know, defining like your equal operators and maybe representation. Or you can use some third-party libraries to do that for you. It's kind of just really speeds up your development. Problem with using third-party libraries, again, why I didn't kind of include it here is because if you do it yourself, the only one, I don't know, maintaining the project, that's fine. But once you have other people there, they need to kind of go to these libraries and start learning them. So you introduce another, I guess, domain-specific language in this one, but you force everyone to go and learn this. So we will stay with like the vanilla Python, you know, what you can do with a Python itself. Now, I kind of continue to use, as you see, this is like really simple kind of toy examples, and the reason is because I want to kind of move focus on the patterns. So here, like, let's say that we have a circle right now, and a circle have a center. This is the point from before, and it has a radius. Now what you might want to say is you want to say, you know what, it kind of makes sense that radius is going to be only positive, so I don't want to kind of include everything in radius. I want to kind of somehow protect this radius. So again, you might start with doing the state radius, and from before we know it's not going to work, right? Because you kind of put like some kind of a sentinel, some kind of a watcher over there to check that stuff, but everyone can access the thing directly, and that's how they'll do it. So you don't really want to do that. Why would you like to protect radius at all? You may say, you know what, why do I care if it's minuses? It depends like how far this thing can go. We, for example, we in our company, we have, we do like bidding, and we have things that call like how much you want to pay per a bid. And that kind of, it needs to be in a sensible range, because if sometimes it goes like beyond the range because someone, you know, mistyped in the UI some number, it gets into your thing, and then you would like to say, I want to limit it. I don't want to kind of pay, I don't know, $1,000 per bid. I want to pay up to $1. So you might want to be able to kind of check these things in certain areas. So how would we do that? So Python have this thing that like an underscore attribute. Anyone seen that before? Used that before? Okay, I guess not. I guess that, you know, maybe some didn't, so I'll expand it a little bit that way. So I'll touch that later on as well, like the differences, I guess, in the attitude in Python and Java. But what happens here, you're saying to your, when you do that, something like that, you're saying to your programmer, hey, this is something kind of private, please don't touch it. And I think the please don't touch it is very important, because if someone wants to, you know, someone have access to your code, they can still go, they can import your stuff, and they can still touch it. But you should know, you should feel really bad if you touch something like that. You should know you're not supposed to. And usually your IDE will also try to warn you. Like if you're using some kind of a maybe PyCharm or some IDE around it, it will say, hey, you're kind of, you know, messing around with some private variables. Why would you do that? So how you can do that, you can say, hey, you know what? I want to kind of start and have this private variable radius, underscore radius. And underscore radius actually is the one that's going to store the real value of the radius. And then what do you do with that? You're saying, I'm going to add something called property from Python that says that everyone who asks for radius, this is like now my getter, but instead of doing get radius, it's just like if you go to your class and do dot radius, it will go to this guy, and it will say, hey, return the self radius. And the same thing happened with a setter, where we can say, hey, everyone who's going to say, hey, my radius, I want to set it to something, you will actually go through this code path. And once you go to this code path, you can do all the checks that you want. And if you're happy with the checks, if the check passed, you kind of set the underscore radius to the value that you want. And this is really, really handy, because what happens here is, again, from the point of view of your client, they will use still dot radius as they are. They won't have to change anything. They won't even know that you're doing it in a way. And you can now add this behavior. So even if you didn't do that, and once you kind of said, oh, wow, we should have checked for radius because it kind of messed up things down the line, introducing this code don't really change your client code. For them, it's kind of still the same. And by doing it like that, you actually get it. What happens here behind the scene, it's something, again, because it's like more for beginners, I didn't really touch it, but you can imagine that if you have a lot of these attributes, you might want to reuse and reuse that stuff. You can use something called like descriptors in Python, and that's what kind of happens here, to reuse this behavior of, I don't know, a non-negative number. So if you want to kind of, if you think this is really useful for your application and you want to use it over and over, I recommend maybe starting with this thing, how it works, and then using descriptors, because you can reuse that that logic. Sure. It is a getter and setter approach, which is not visible to the client, but that's what your client expects, right? So if your client, everyone uses the radius here and there, what you're actually doing here, you're kind of putting a guard on that, or you're adding some behavior to that. It's a getter and setter, but sometimes you want to kind of protect these instances. Sometimes it makes sense. Yeah. Yeah, so the different, you're definitely right. So the question here is, it's the same as getter and setter in Java, just that in Java it's explicit. Here it's not explicit. The thing is that in Java, that's how you would usually use your getter and setter. That's how you'd expect. And here, you don't have to. You don't have to do this behavior. And once you add this behavior, you don't want to kind of introduce a new method to your client to kind of tell your client, hey, you want to use this guy from now on because the other one is broken. how would you be explicit about it then? Well, the thing is that when you do a set radius, you can even call a function, but the thing is that you want to introduce that, or when we wanted to do something like that, we wanted to introduce that without changing our clients. Without telling our clients, now you have to change all your code, but still maintaining a certain behavior, a certain logic. But I think that I get what you're saying. I think that what you're doing here anyway. When you do dot radius something, you're setting a radius, and you shouldn't really set a minus radius if you shouldn't really do it. So you're kind of saying, hey, I want to watch this because you are setting a radius, but I just want to be really easy by watching it. Like, right, no, really not being hammered on you and like passing a lot of responsibility to you now as a client to kind of call the right guy. Is that okay? All right, so now we're moving to kind of factory methods. I think this is something that one of the things that kind of happened to me, I don't know if it happens to many others, I think it does because I've seen something similar to that, is that in Java you always know what you're getting in terms of your classes, in terms of your code. So you might have like a var arg that it kind of, it's actually an array behind the scene, but you know which type of stuff you're getting. And in Python, you don't, because it's kind of dynamic, right? So you might sometimes get away with that or get ahead with that and say, you know what, I'm getting something and I can get whatever I want, and then later on, because I get whatever I want, what I can do is, try and guess what it is, and from that, I can continue to continue my execution. So for example, you can say, I have a circle, and now there are different paths in my application that kind of creates circles. So some circles want to be created from other circles, and some circles want to be created from a point and a radius, and some circles I want to create them from maybe like coordinates and a radius. So you're getting these args over there, and you might say, you know what, if the length is 1, then I can assume this is a circle that I'm getting, so I know how to do it from a circle. If the length is 2, then I can assume it's a center and a radius. If the length is 3, I can assume it's coordinates and do it from that. And I've seen kind of similar code like that again in like some stuff that we're getting, because you can get everything, so why not check for everything? I think this is not so great, especially now when we're going to see the alternative. And it's not so great because you're guessing. And usually to guess is not really great. And I think that's kind of back to your point of being explicit. Usually your caller know what they have in their hands. We're not talking here about like an error state. We're talking about the caller got it maybe from a database. In the database, he knows that he's getting like the 3 different things, the 3 different columns. So provide a path to your caller to create a circle from what they have. So how can we do it? So you can say that your initializer is always like initializing from a center and a radius. And now you provide a path to your caller to go with what they have in their hands. And once you have this path, you can check several things for that, because you know exactly what you're getting. But now you can say, hey, I'm adding this, I'm having a factory method here that says, if you have a circle, you want to create one, so they from circle. So you kind of take a circle, and you're saying it has to be of a circle instance, and then you instantiate basically a class method, an instance with that class method. So what you're using here, this kind of class method annotation, or decorator, actually, it's a decorator in Python, to return these guys. And this is back to maybe your thing of being, now you're being explicit, because now you're not talking about an error, you're talking about a place where the caller knows exactly what they have in their hands, just give them the path to do it. Another value of doing it this way is that in here, I'm only going through the code path to check for a circle. I don't have to check every time to go through the initializer and go and check every time, although the caller knows what they have in their hands. You can also obviously continue that to say, if you, no, sorry, I think it charged too. Okay, Yeah, and you can also do it like from coordinates and a radius, etc., etc. But basically, this is something again that we use quite a lot. I found it really useful. It kind of, in the same way that you have maybe factory method of a new instance in Java, you just kind of have the same guy over here. I'm just gonna add a little bit behavior right now to these guys, and I'm gonna add a little bit behavior so we can start talking about the decorators and the decorators and basically how they can be used as adapters as well. And I'm specifically using something which is quite simple, and I'm not using the redundant kind of thing for that, so it would be again on the simpler level. So let's say that we have this behavior of saying contains, that we can say that our circle have a contains that says you give me a point, and the circle will say whether this point is inside the circle or not. Yeah, so quite a simple behavior. The distance here is we can assume it's doing what it's supposed to do. On the code samples it's actually implemented. It's really a simple implementation. And we say, it's contained if it's within the radius. Actually, I will go first to how we kind of not do it. And now we want to do even something a bit more. We want to do something before the contains being called. We want to kind of start measuring the time. Maybe it takes us a long time to kind of compute it, and we want to be able to write it to the screen. So we kind of do something before. The important bit is that we do something before or we do something after, and we add some behavior to these contains. And we can imagine that we have different shapes. We have circles, we have squares, everyone implement their own contain. And now if we want to add it, we have to go and start copying this guy over and over. So how would you solve it in Java? I guess you will use inheritance sometimes, right? So you will say, hey, I have some kind of a thing, it's called a shape, and a circle is a part of a shape, and maybe a rectangular is a part of extending the shape, and you basically extend the guy. So I think most people will see that this code is not really nice in Python. The also inheritance kind of lost a little bit out of the, kind of got a bit out of grace. I think that's because it's really hard to go and see what's happening in inheritance. When you start like having multiple inheritance, it's becoming really, really hard to debug and understand which one is calling who. So the calling chain is being really convoluted. So let's not try and use inheritance. The one that kind of is more popular right now is to use composition. Instead of like inheriting something, you kind of say, no, I'll kind of, you'll be part of me, so and then I will call your call. So then it's kind of clear which one is calling who, right? So you can say maybe you have a composing shape that kind of takes the shape, and every time someone calls contain, you might want just to call contains on the point. This is actually even worse in Python, in my opinion, and the reason it's worse is because now you have to start implementing all that stuff that the shape's supposed to implement. And while in Java, you might say that, this one implements an interface, and you'll see a compiler error if you forgot something. Python don't do it because, everything is dynamic, so you might miss some code over here, and then you'll get a runtime error because you forgot to implement one of the things that the shapes are doing. So what can we do? So I think here decorators come to the rescue, and again, this is something that kind of took me a long time to get my head around, because it's a function that takes a function and returns a function. That thing didn't really exist in Java when I was developing. Now with like Java 8, it's with all the lambdas, it's becoming a bit more useful, and with functional languages being more popular, it's kind of something that kind of gains popularity. But Python was doing it for quite a while. Functions are for citizens, so basically we can say, you know what, let's time this function. How we can time this function, we're just gonna take a function, and we're gonna return another function that time it. And inside that function, in the middle, we call ours. So we're basically saying, we're taking our function is gonna take a callable, it's this contains function. It defines another callable that it's gonna return, that's the name of the wrapper guy. And the callable is being callable on a point because we know this in this occasion, that's kind of what it takes. That this is the parameters. So far, so good? Okay. And now how we can use it, we basically just define this kind of @timeit and put it on top of contains. And this is like a syntactic sugar, which is really useful in Python to say, hey, when contain is being called, actually, I want you to wrap it with this timeit guy. And if you remember, we saw something really similar before. It's not new, actually, even in this talk. We had the property guy, and we had the class method guy, and that's how they work, right? They're wrapped. They kind of add some behavior to an already defined function. And now what happens is that when you define this guy, Python will store under the contains function, it will store actually the result of the timeit. So the callable after we call timeit on contains. So the question here is sometimes, in this case, we knew exactly what we're calling at. We're calling on point. And because we called on point, we knew exactly how to call the function that we were wrapping. And here I'm adding a little bit of a few behaviors. I'm going to go through each one of those kind of yellow ones one by one. So I guess the first one is just the functools.wrap. So basically, when we wrap a function, we also sometimes want to kind of keep it tidy and basically say, hey, I want you to also wrap the name of the function to kind of, tell that the name of the wrapping function is the name of the other function. It makes it really nice for introspection, and then you can see when you kind of look at or debug your code, you can see what's going on. It might also kind of change the doc. So functool kind of make sure that all of this happens. So do use it. It's kind of part of the language. Just instead of wrapping it yourself, just say, hey, you know what? Help me to wrap the function over here. Another thing that happens is that we have args and keyword args that basically says all the positional and all the keyword arguments, just pass them on. So everything that you pass to the callable, just pass them on to the function that I'm wrapping, because it's the one that I want to kind of mimic its behavior. So that's instead of point. And another one is that if you remember in the first time, I just printed the duration. So it's just printing to standard out. But you might want to be more specific about it. You might want to say, you know what, I want to actually specify what is the writer. Writer is something that implements a write. And now you can kind of say the writer maybe standard out, maybe it's a log file. And that's something we also use something like that in production, for example, when we're saying we have different endpoints. Each endpoint we want to say write to a different log because it kind of have a bit of different behavior. So we kind of say, all right, wrap it with some logs to, and the logs to this file. It also makes it really easy in testing because then you can say, it logs to this string IO. Everything that kind of implements a write, I can go and inspect it later on. And I think the other thing that happens here, which is really interesting and also kind of takes some time to kind of get your hand around, but this is the adapter pattern, is that actually when we call write time to, we call it with a writer. Right? We actually give it something that you can write to. But what we get back is a function that you can call on a point. So we change the behavior or kind of parameters that the function is being called. Right? We started with a writer, and now we have a callable that we can call on a point. And this is something, again, really useful if you have, for example, some implementation of something that takes a certain arguments, but you want in your application to add some arguments or to add some behavior or to change some of the behavior. Then what you can do is use this decorator. For example, you have a WithG application. Your WithG application, you pass two variables, its environment and respond, which means what's in the environment and how do I respond to the thing. But in our application, we also want to kind of say, you know what, sometimes we want to bid, sometimes we don't want to bid, so we want to add some flag to say how you're supposed to behave down the line. So you wrap this kind of function to say, you're wrapping this guy, and now you return a callable that takes 3 parameters. And now we can continue in our application with a 3rd parameter. And how are you using it? So here I'm kind of adding this guy. So I'm saying write timeit to, and I'm writing it to C standard out. This is exactly the same as print, but you can imagine I could put it somewhere else. It's 5 or -5? Okay. And I'm also showing here that we can add a functools. We can add another behavior. We can add another wrapper over here, for example, to cache it. So if this is a very expensive operation, for example, we might want to say, you know what, every time it's being called with the same stuff, we might want to cache it and not go through the operation. So again, we're changing the behavior. We're short-circuiting contains over here. And the way it's being called is that the top one is being called first, then we have the second one, and then we have the last one. So in the way that we order, that's how we're actually calling it. So we're going to write it to the standard out. Write, we're going to call functools. Functools is going to decide whether it's short-circuiting contains or not, and if it's not, it's going to call contains. Any questions on this? Nope. Okay. So, some places that I kind of reference from. As I said, you know, when I started in Python, was not Java. I kind of started trying to look around. It looks like there's someone who already said Python is not Java. I think it's a really good read. And he also said after he wrote that, there was a lot of backlash. So he also wrote another post saying, OK, Java is not Python either, when he kind of compared it from the Java point of view. If you want a lower level comparison, Python for Java programmers, have it. It's a lot of, it's a list of the changes. I think it's a good starting point to kind of understand at least what you're dealing with in terminology. I really like that book, especially all the chapters on functions. I think it's explained really well. So again, if you're starting or you already know some language, you want to kind of get deeper into that, I really recommend this one. And more advanced reading, how we can use closures to optimize Python calls. This guy is actually a disclosure. Yeah, this guy's working with me. And Python descriptors demystified, that's what I was talking about the if you want to do the radius stuff or like have the same behavior of a non-negative number over and over, this is something you can read, and I think it's also really useful. So the conclusion is Python is not Java. I think this is quite clear. But I think a bigger conclusion that I kind of came to after this change, maybe not so kind of earth-shattering, but languages like programming languages I think are really similar to spoken languages. You can kind of copy a few things, but in a new language that you learn, there's lots of constructs that you have to kind of learn, and you can be okay with the language and be all right, like say your name and I don't know, how do you go to the beach, but then it's really hard to get fluent with that. So it takes time, and I hope that this can help in facilitating your knowledge or facilitating your move to the new language. It's also, though, I wouldn't go too far with using a lot of decorators one over the other, because it just complicates your, it's almost the same like inheritance, although it's not. But if you put too much, it's really hard to follow the logic of your application. And I also wouldn't be too protective about everything, because in Python it's kind of I think the idea is like, trust your programmer, don't restrict access unless you really, really have to, and let people, do what they do. Whereas in Java it's more encapsulate as much as you can and give as little control as you can to the client to basically change things. So don't overdo it with Python, because it's not really built for it. And it's also kind of obscure code. But if you really have to, like I think, again, we have some places where we really have to because we want to make sure we're not losing a lot of money, then do it elegantly. Do it with as little impact that you can on your clients. I think that's all I have. Yeah. Thanks.
There are some questions. Okay, so thank you very much for your time.